I have a geometry I have in this project, and I have designed it. Then I meshed it, and now we are going to set up. So once I open the setup menu, okay, okay, click on OK. If we want to add potential, voltage potential, energy source term uh, across any two electrodes. Today we are going to learn it, how to add in ANSYS Fluent. So I have launched the ANSYS Fluent setup, and my solution is now the case file and the data file. This is setup. ANSYS workbench is reading. It take about 30 second, 40 second, and we move to the subject. Our subject for today. Okay, you can see it's reading now. Okay. Okay. So here is a geometry in which we have two inlets. Here is one and the other one is here. And at the top side we have outlets. So I have set up this. Now I have components. Let me show you. Go to the cell zone condition, fluid domain, air, solid domain. We have anode, cathode, and the body, outer body. So you can see this one is my anode, and in the middle of anode is the outlet. This one is cathode down there, and my body is outer shell. You can see this one. Okay, now I want that there is some power dissipation across the anode and the cathode. So we learn about how to add that power dissipation factor at the anode and the cathode in this video. So first of all, go to physics, make sure this term is energy is selected and your viscous model is selected. Then go to this cell zone condition. Go to anode, click on anode. Now add a source terms. Here you see source term. My anode is of copper and I am going to add a source terms. So this one is my energy. So let's see it. I have already added it. Now okay. then it's 0. Now I am going to add energy sources. I have add in one energy sources. You can add the number of energy sources like this. Okay, so I have added an energy source term, and my power dissipation across this component is 3 triplet triple zero watt per meters cube. Okay, so I edit this energy source term and click on apply and so on. Now I want the same for my cathode component. Source term energy, and I have added the same energy dissipation or power dissipation across the cathode as well. Okay, click on apply, close. Now the second thing is how to add potential difference across the cathode as well anode. So for that, go to models, click on potential electrochemistry model, potential equation, and click on OK. So now go to anode. So now we have potential sources. Edit 1. Okay. Now if I have a constant value or there is some expression which shows how voltage is changing, then we can put an expression or we can add a constant value. I have a constant value, so I could add that. So I am adding 50 ampere per meter cube. The current is flowing from this source. Okay, like okay, apply, close, or you can add fixed values. Fixed value of potential is 200. Okay, so in the previous case we have a source term. Source means any energy sources. So if we have potential difference or potential at the anode, then we add the fixed value from here. Okay, if we know the temperature of the source, anode, cathode, then we can add the same like this, 200. Okay, so click on apply and close it. We can do the same thing for the cathode component. Click on fixed values, add potential, constant factor 200 or 250, and so click on apply and close. So this is the way how to we add potential difference across the cathode and anode, or energy dissipation across the cathode or anode, or any component which is dissipating power in my geometry. We can add it, go to cell zone condition, select the component, and then in components add source terms or fixed values of the desired parameter. So hopefully you understand today concept about how to aid energy dissipation as well voltage or potential across the cathode or anode. There are other things to learn. We can include joule heating, which is resistance heating due to the resistance as the current flow in the battery or anything similar in any electrolysis process. So the heating produced is called joule heating, and we can also configure it by selecting this include joule heating in energy equations. Okay, we later on learn about these concepts. Okay, so hopefully you understand today topic. If you have any questions, you can ask me in the comment. I will